Hello, Bachu. So today the topic we are having that is maxima and minima. Okay. So that topic comes under calculus and the chapter name is application of derivatives. So let us start. First of all, mathematics, like the whole section comes under mathematics only. So mathematics is something which is based on numbers. Now those numbers we can put on the number line or we can put on the xy plane, and for those numbers we have to analyze like which point is going to be maximum and which point is going to be minimum. Okay, so let's start. What we can do here, we can represent the numbers which we can see in our real life in xy plane. So what is going on here basically, we are having a function y equal to fx, and for this function we are giving some input and getting some output, and now these input output we can show in the form of coordinate in the xy plane. Okay, so for example, if I am giving input as 1 and getting output as 2, so that I can show in the form of coordinates in xy plane. So that 1 is nothing but distance from x-axis, 2 is nothing but distance from y-axis. So I can show the point like this, and in the same manner we can put lot of points. Like this we can put so much points here. Suppose that is a scenario we are having. Suppose this situation we have. Now, for this scattered points, what they will ask? They will ask, figure out which point is going to be local maxima and which point is going to be local minima. Now the thing is, you might say like this is the graph we are having, and by looking at the graph we can directly give the answer. Obviously we can use our common sense and give the answer. Okay, so that is applicable here. So what you can do, what you will say basically, you will say okay, look at this point. This seems the bottommost point, this one seems to be topmost point. So this is going to be minimum and this one is going to be maximum. That is correct. What about the values which are lying in between? So for the values which are lying in between, like this, what we can say? So this value is nothing but local maxima and this value is nothing but local minimum. How we can figure out? So for this we have to develop the logic. The logic says, suppose this is the point, and for this the corresponding x value is c, and for this the corresponding x value is l. Now the logic says if fc value is greater than fc minus and greater than fc plus, then this point is nothing but local maxima. That is the logic. Okay. Now for this point, which is fl, if this is less than fl minus and it is less than fl plus, then this value is nothing but local minimum value and this L is nothing but local minima. Like for this FC is nothing but local maxima and C is like this whole one is local maximum value and while C is local maxima. That is the point basically we are having. So what we can say here, this FC minus is nothing but we are moving towards C from left side, and FC plus, like C plus is nothing but we are moving towards C from right side. So that inequality says basically if you are moving towards C from left side or right side, from both direction the value which you are getting that should be less than the FC value. If it is applicable, that shows this C point is local maxima and FC is local maximum value. Now for this L, as you can see, if you are moving towards L from left side and right side, both side the value should be greater than FL. Then only we can say this L is local minima and FL is local minimum value. So that is the condition we are having. Okay, so we were having some set of points which were scattered, which were discrete. Now those points we can put on the xy plane, and then by using this logic we can derive which one is local maximum, which one is local minimum. Global maxima is the topmost point, global minima is the bottommost point. It is also a part of discussion, but that require more understanding of calculus. But right now our focus is to understand local maximum, local minimum. One more thing, as you can see, right now we can't say like we are having more than one local maximum value, but that there is a possibility we might have more than one local maxima, we might have more than one local minima, but global maxima and global minima for a curve, for a function is always unique. That is clear. You might have more than one global maxima also, but all those should have the same value. This is the point. Now, in this method, the problem is basically right now we are having the information, we are having the data, and then we are able to figure out the result. There might be a possibility that you have to derive the points where the function can have the local maxima, local minima. Right now we are having the points itself, and then we are trying to figure out the result, but you might have to derive the point also, like the x value. Then what we can do? So for this we are having second method that we call as first derivative test. So the second method we are having for local maxima and local minima, that we call as first derivative test. Now in this, the method we are having first derivative test. Now here basically what is going on? Simple. If we are having a random curve, that random curve could be like this. This is the random curve we are having. Now for this random curve, someone is asking, figure out the local maxima and local minima. For this one, when the data is scattered, function is not differentiable as well as continuous. Okay, so that shows if function is not continuous and not differentiable, still it can have local maxima and local minima. And to figure out, we can use this logic. This logic is also applicable for this. It is always applicable. But the problem is, if we have to figure out these points, these x value, so how we can figure out? Earlier we were able to get these values directly, but you might have to derive the values. Now for the derivation, we have to use this first order derivative test. Now for this, if we are having a function y equal to fx, and for that function we are having input as x and the output we are getting as y, and now these we are representing on the xy plane by joining the points. Since all points are available here, so we can have the continuous graph, and for that graph you have to figure out the local maxima and local minima. By the way, by looking at the graph you will say this one is nothing but like global minimum, and this one is nothing but global maxima, because this is the bottommost value and this one is the topmost value. But what about the values which are lying in between, like this, and like this? This one also. So for this we have to look at the geometry logic. What is that geometry logic? Suppose there is a person who is walking on that curve. There is a person who is going to walk on that curve. So when that person will start to walk, what will happen? From this point, when he will move upward, he will reach to this top point. After that, he will go downward and will reach to the bottom point. Again, he will move upward, will reach to the top point. Again, he will go downward and will reach to the bottom point. So that is the scenario that is happening. In that moment, what is going on basically? In terms of geometry, when he will try to plot a tangent at any random point, suppose we are going to plot a tangent at any random point, what is going on for this tangent? As you can see here, initially we were having this one as the slope. If I show you the tangents, this one is the initial tangent, like this we are having. Now after that, tangent becomes like this, and then after that it becomes horizontal. So what is going on? This angle is decreasing continuously, becomes 0. Then after this, for this tangent, it becomes negative. What is going on? As you can see, around this point, just before to it, that tangent, that angle is acute. After this, it becomes obtuse. Means theta, earlier it is behaving as acute angle. After that, it is behaving as obtuse angle. If we will try to figure out the slope of tangent, so slope is nothing but m is equal to tan theta. Around this point, before this, we are having m as negative. This one is positive. Before this, we are having m as positive, and after this, we are having m as negative. What is the observation? Observation is, if whatever point you are having around this point, if before this the slope is positive, after this the slope is negative, then this point is nothing but local maximum. Like for this, just move left to it, like from left side move towards this point. What will happen? slope is positive only. At this point it becomes 0. After this it becomes negative. So that shows if it is local maxima, we should have slope changing from positive to negative around this point. Now what about this? For this point, when we will draw the tangents, earlier it is negative, after this it becomes positive. So that shows if slope of tangent is changing from negative to positive, it's nothing but local minimum. If it is changing from positive to negative, it is nothing but local maximum. So by this method we can derive whether the function, whether the point is behaving as local maximum or local minimum. Now what is the process for that? So we can have one example. Suppose we are having the function is y equal to x cube minus 3 by 2 x square. Now for this someone is asking to figure out local maximum, local minimum with the help of first order derivative test. Now how we can figure out? Simple. The method says first of all try to derive the equation of differentiation, like try to derive the equation of slope. So how we can derive? When you will differentiate this, you will have dy upon dx is equal to 3x square minus 3 by 2 2x. Simplify this, you will have 3x square minus 3x. Now this is nothing but equation of slope. Now this slope is nothing but whatever slope we are having, this is nothing but slope of tangent at different points. Now when we will equate this to 0, that means we are trying to figure out the points where tangent becomes horizontal. So 3x square minus 3x is equal to 0, we are having x is equal to 0, 1. Now this shows we are having 2 points possible where we can have local maximum, local minimum. There is one more possibility, we might have point of inflection. It's a different part of discussion, but we might have more possibilities. Means whatever observation we are having, for this we can have local maximum and local minimum. It's not sure like we will definitely have, but we might have. Now for the derivation, how we can figure out it is local maximum, local minimum? So the concept is whatever result you are having, whatever equation you are having, 3x square minus 3x, just break down this like this only, 3 times x, x minus 1. Now 2 points we are having 0 and 1. So for 0, try to figure out 0 minus and 0 plus. So for 0 minus, when you will put the value here, that is going to be negative, and 0 minus, it's again going to be negative. Negative becomes positive, means for this 0, the overall result is basically, for 0 minus, it is positive. Okay. Now for 0 plus, when you will figure out, that becomes negative. That means around 0, the slope is changing from positive to negative. That shows 0 is nothing but maximum. Okay. Now let's look at for 1. For 1, what you will do? Just try to look at the 1 minus value. When you will put 1 minus here, what is going on? 1 minus means some value which is just less than 1. So whatever is that value, it should be positive only. But for this, when you will put here, subtraction will produce a negative result. So for this, it is going to be negative. And 1 plus, that is positive, overall positive we are having. So that means it is positive. Now minus 2 plus, that shows it is going to be minimum. This is one of the methods that is very confusing kind of, because you have to do the observation method. So to avoid that, we can use number line method. From there we can directly have the result. So what you can do, you can just take these numbers and put on the number line. So we can put these numbers on the number line like this. We are having 0, 1, plus in front, minus in front. Now start from the rightmost point, put the plus point here. Now around 1, look at the 1. For 1, what is the factor? This is the factor. Look at the power. Power is odd. If power is odd, sign will change. Now for 0, which one is the factor? This one is the factor. What is the power? Again odd. Sign will change. Now for 0, sign is changing from plus to minus. Means it should be nothing but local maximum. For 1, minus to plus. It is nothing but local minimum. And that is what we were getting here. Plus to minus, local maximum, and minus to plus, local minimum. So 0 is local maximum, 1 is local minimum. If someone is asking for the values, so value we can get by putting on this. We can have the value also. So if someone is asking for the local maximum value, so that value is nothing but y equal to 0. And if someone is asking for the local minimum value, so you can put here, that becomes 1 minus 3 upon 2, answer is minus 1 upon 3. So that is the value we are having. So I hope you guys have understood this concept. Thank you.